Hello, good day everyone. In this video, I would like to show you how to plot the Hooke's law graph using Python. Specifically, I will be looking at a Y question, Physics May, June 2011, which is shown on your screen right now. You can see from the table there, you have a table of value containing mass, weight, and extension. So the first thing to do is to put this data in Excel. So what you do is to open an Excel workbook. So you enter the detail, mass, and extension. Of course, by the way, what we have to plot, the graph we have to plot has to be weight and extension. And of course, we have to also put the extension in meter, but all this can be done. We can manipulate all this data with Python. So let's just save this file as CSV. I prefer to use CSV, though you can use other formats. Python can read from other formats as well. So that I'll be using. So let me call this Hooke's law. I want to title, so I have to change the save as type. Save as type, you save it as CSV, delimiter. Then let me save it on my desktop. Save it on my desktop. So I'm saving it on my desktop. So as Hooke's. Okay, I'll just click here. Don't worry about it. So of course, the next thing to do is to go to Google and open Google Colab. Open Google Colab, to take you to this page, and from this page, just click File and click New Notebook, and you get it. So I can decide to label. So usually this is a notebook, and it's always saved as IPYNB. So let me title this also Hooke's law. Let's see how it works. Okay. So the next thing to do is to start coding. So what you do, you start with importing your various library. So you import Pandas and PD. This will help in data manipulation. Also for visualization, you need Seaborn and Matplotlib. So you import Seaborn and SNS. Can also set the default set. Okay, then let's import matplotlib. So these are the libraries we need to do this. So when you are done with this cell, you click on this play button. So what it's supposed to do is to run the cell. So it's running now. So when it's done running, you have this. So don't worry about this comment. Just go to the next cell, click on this plus code. So what we want to do here now is we want to import the Excel file we saved earlier. So to do that, just type from Google.Colab import file. files, so an instance of these files to upload. Then let me title my, now I want to read from the CSV files with Pandas now. Let me type this also Pandas read underscore CSV. Now since I label it, I label my file, my Excel file, it's a CSV file. Then, so if it's done loading, I want it to read from the file as well. So let's see. So this will prompt you to upload your file. Then it will read the file and display it. So you will see this now. If you quickly click on choose file, so from choose file to take it to the location, so you can quickly locate. You see my desktop. So what I need to look for, which I have right here. So once I'm done, open this, then it will be reading. It will read it, then it is of course displayed. So the next thing I would like to do now, the data in the Excel is now here on my notebook. So now I can play with it any way I can. So what I would like to do, if you go back to this, you will see that you have a table of mass, but you need to work with weight. So what I'll have to do is I'll have to calculate weight from the mass, and I should also convert the extension to meter. So how do I do about that? So let me go to another cell. So click this plus code. So what I will do is, since oops is the title of my, so oops, and one of the, of course, column. So I want to create a column titled weight. So I want to create a column titled weight, and how I want that to be done is I want to divide the mass. I want to divide the mass. Now I want to multiply the mass by 10. Since we are given weight equals to mg, so I have to multiply the mass by 100. So this will store this, create another column in weight. So what I will now want is, I will want just to have, oops now, but I only want to have, I want to have weight and as well extension. Weight, comma, then, so I don't want it to display the mass for me anymore. Just give me the weight and extension. Oh, before that, also I want the extension to be converted to meter, since it's centimeter. So I also have to do this. Oops. Then now I want my extension. I'll say extension in meters. Let me just put it like this. Equals extension. So that will be divided by data divided by 100. Since 100 centimeter make 1 meter, so to convert it to meter, divided by 100. So I've converted my mass to weight and I've converted my extension. So I want the one that will show me the. So I just want to display this alone. So let's see what scopes will give us that. So let's run this. Okay, so you see you have a graph of you have a table of the mass, extension, the weight, and the extension in meter. So the next thing to do is to go to the visualization. So let's go to the visualization where we'll do the plotting. So let's try a line plot first. Let's try a line plot. Let's try a line plot, then we can then decide if we need a rect plot on there. Let's try a line plot. So that if we're just using a line plot, we can easily determine the slope of our graph, which is what we actually need. So let's do SNS dot let's set the arrow. Set by 8. Okay, let's label our plot here. Seaborn, that line plots. Our x-axis is our extension in meters. Extension in meters. So let's also put that. Then our y will be our weight. Markers to be true. Let's put markers to be true. Let's use the marker small row. Then our data should be read from hooks. So I want to put color to be green. So having done that, we can also title our graph, which is also very good. So let's just do ax dot let's set the title, set and the title. The graph of weight, extension. Okay, let's set the font size and the weight of this label. let's set it to be 16 and the weight, let's set it to be semi-bold. Okay, so I think with that should to have something. Okay, let's check that there's no error. Okay, so let's run this. Okay, so you have your graph here. Okay, not entirely very straight, so I will advise that you probably just do a rect plot. Let's just do a rect plot instead of let's try a rect plot to see what we have. So I do need to I'll just copy this, create another cell, put it there. So I change this to I remove the line plot and work for your red plot. Then this is not a red plot. Selecting this color to blue. Yeah, I think done. So this will more be like a regression plot, which is more appropriate, I think. Okay, so this is better. It's better, so we can just choose. So evidently, it's passed through these 2 points, so we can just choose these 2 points from the graph, so to determine our slope of the graph. So that way, of course, in a graph of force versus extension, the slope is the spring constant. So for what you can have here, the points 10,000 and 20,000 weight will clearly give us and what are the values of the extension there. 0.200. Okay, let's try to calculate the force constant, which is the slope. So say let's just do the numerator, because we know that. So the numerator, if you check the graph there, from this graph, numerator that will be 20,000 minus 10,000. So let's put it as a float. 20,000 minus, also as a float, 10,000. Then the denominator x. So that would be to check. Clearly also we have 0.200 and 0.110. So let's have float 0.200 minus float 0.110. Then our k, which is our spring constant, which is the slope, or let me call it slope k. So k will of course be numerator y divided by the numerator y divided by denominator x. So then I need my value of my k. So I just wanted to do this, calculate the value and give me the value of my slope. So what do I get? Oh, I get 1 111,111.111. Okay, to confirm that you should. It's very correct. Okay, so the next question asks us to calculate. So the spring constant is the slope which you have calculated now. Now we are told that if the natural length is 38 centimeter, calculate natural length if its length is 38 centimeter when loaded with 250 gram mass. So of course, what we need to calculate there is the extension first. Since we know the first constant, which is k, so extension will just be the weight divided by the constant. So that will give us the extension first. So let's do that with another cell. So let's say I need a new extension. Let me call it new extension. So that will just be the new weight, which is 50 grams. So that will be 2500 newtons. 500 newton is 50 grams divided by slope k. So what is the value of the new extension? And if I have my new extension, which is in meters, mind you, how do I get my natural length? Extension is the new length minus the natural length. So let me just make a note here. You of course know that extension equals new length minus natural length. Definitely, natural length will be equals to new length minus extension. New length minus extension. Now in this case, our new lengths were given in centimeter, so you have to convert it to meter. That will be 0.38 meters. So that will be, just say natural length. Natural length will be equals to 0.38 minus the extension. So let's just call it the value of the natural length. So what should that be? So let's run that. So the natural length is 0.3575. Natural length is 0.3575 meters, which is equivalent to 35.75 meters. So okay, so that's just all about it. Let me quickly run through it. We import our libraries, in this case Pandas for manipulation of data, Seaborn and Matplotlib for visualization. Then the next cell will upload our data into the Colab. Then we do some manipulation on our data to calculate to determine the weight and also the extension in meter. Oh, I think there's an error there. We have an error here because our weight should be multiplied by 10, not by 100. So that's just a mistake. So let's quickly correct that. So we do that. So it doesn't really affect whatever we are doing. We just need to rerun. So we just need to rerun. So that's the beauty of coding, because imagine this is a graph now, you have to probably replot, making this mistake. So where we do the slope is just also make another adjustment here, which is to correct the 20,000 to 2,000 and this to 1,000. So I think the points are still the same. So let's just do that. Okay. Other things also remain the same. So value is 0.155. Which is 15.5. Alright, so I think this is good enough. We can, this is just a guide on how to plot our graph and calculate slope. In this instance, we're focusing on Hooke's law. So I hope you grab the idea and you understand one or two things about how to plot a graph in Python. So thank you for listening.